Hiya everybody. I hope you're doing okay. Hope you've had a good day. Welcome to our biology lesson for this Wednesday. We're going to be learning all about the heart and the cardiac cycle. Hope you're all excited to learn more. Just first of all, can you make sure you can hear me? Can you put a plus in the chat to let me know that you can hear me okay before we get started? Hi. Hi Celeste. Hi Chloe. Put a plus in the chat, let me know that you can hear me, and then we will get started. Brilliant, thank you. Hi. Thanks guys. Okay. So the goal of our lesson today is to go through the cardiac cycle. We're going to start with some kind of basic heart structure, making sure you can all label the heart and the chambers and the blood vessels. And then we're going to go into some more complex A-level biology, which is the cardiac cycle itself. Okay. At the end of the presentation, I'll talk to you about the A-level biology course that we're launching in January. So make sure you stay on till the end of the lesson so you can hear more about that course and how it can help you prepare for your A-level exams. Make sure that you all get those A's and A stars that I know that you all want. So stay on till the end. We'll talk more about that then. So I don't know whether any of you have been to any of our free streams before, but just to get to know you a little bit, just let me know whereabouts in the country you're from. You can tell me what subjects you're studying. You can tell me why you love biology, because I'm sure you all do. You can also feel free to type in the chat if there's any topics, other topics that you do want me to go over. I don't know if any of you follow on TikTok or Instagram, but you can let me know if there's anything that you want me to go over on there. So yeah, just start typing into the chat, introducing yourselves, where you're from, or any other topics that you want to do for your A-level biology revision. Okay. Yeah, got people from all over, which is great. Manchester, that's where I'm from, Manchester. Portsmouth, Oxford, London. It's great to have you all here. Fab. Biology, chemistry and maths, difficult subjects. Okay, let me tell you a little bit about myself while you're typing your answers into the chat. My name is Laura. If you've not been on one of these live streams before, I'm a fully qualified biology teacher. I've been teaching now for 15 years, both in schools and sixth form colleges. I'm from Manchester. I went to Manchester University, studied biology. Currently live on the Wirral, which isn't far from Liverpool. If any of you know it or are from there, let me know. I have a lot of experience, I'd say 10 years almost, 10 years of experience working with the exam boards as well, which means that I am in a really good position to help you with not only your biology knowledge, but with the exam technique, how to approach the questions. And in this stream today, we'll look at a few questions together as well towards the end of the session. Okay. So that's a little bit about me. Let's just talk a little bit about the stream today. The most important thing is that you all enjoy the stream and that you all learn lots and go away feeling really enthusiastic about biology and wanting to do more revision, and hopefully join some of my live streams that are coming up over the next 3 weeks. Make sure you ask as many questions as you would like. There's no silly question. So type it into the chat. I will try to answer as many as I can. If there's anything that you don't understand as we're going through, make sure you do put your question into the chat. If I can't answer it, then one of the moderators, if I don't see the question, one of the moderators will answer it for me. So you will get a reply. There are moderators in the chat just to help me answer all of the questions. So we've got a question already. Is this for AQA? This content today is suitable for those of you studying AQA biology, but also OCR biology. I don't know whether you're asking that question because you're doing AQA or OCR. Let me know in the chat. But yeah, this content is relevant to both of those exam boards. And it's also helpful with GCSE biology as well. I know in the past couple of streams we've had some GCSE students, and some of the content may be too detailed for GCSE, but the heart is a topic that is on GCSE. So it's going to be useful if you're still in year 10 or year 11. Yeah, Edexcel as well. You do the heart and Edexcel. So it's going to be useful for all of you. Okay? If you stay till the end of the session, which I'm hoping you all will, you will get your study notes. So we've designed some professional study notes for today's lesson with all the diagrams and all the notes you need, as well as the questions at the end of the session. So you'll be able to get your hands on those study notes, and we do the same thing for all of the free streams. There's always a set of study notes that you can access to go back over after the lesson. Right, let's get started then. I hope you're all ready to learn. Right, this is the heart. Okay, now if you're GCSE or A level, you're going to have to label the structures of the heart. Let's just start with the basics, which we've got on the board right now. The right side of the heart, which is this side. Doesn't look like the right, does it? When you're looking at the screen, that looks like the left. But remember, the heart is in your own body, so you've got to imagine it flipped inside your own chest. So actually, this side that looks like the left on paper, this is the right side of the heart. Now, the right side of the heart tends to be shaded in blue when you see it in a textbook or revision guide. And we've shaded it in a blue colour as well, because the right side of the heart deals with deoxygenated blood, okay? That side of the heart sends the deoxygenated blood to the lungs. Over here, we've got the left side of the heart, which you'll see coloured in red, because the left side of the heart deals with oxygenated blood. So it's come back from the lungs, it's now oxygenated, and the left side of the heart is going to pump that blood all around your body to all of your body cells so they receive oxygen for respiration. Just wondering, by the way, who feels confident with this? Put a plus in the chat if you feel confident with your heart labels. If you think, yeah, did it at GCSE, already know how to label it. If you're confident, which is impressive, put a plus in the chat just so I know how many of you already feel good about this. Lots of pluses. Okay. GCSE chemistry. Don't know who you are, but lots of pluses. Yeah, good. This is on the GCSE specifications as well. So I'm hoping you feel confident already with your labelling. But let's go through it, okay? So we've got the right atrium, which is obviously the right side of the heart, but it's the top chamber on the right-hand side. We've then got the right ventricle, right side of the heart, but it's the lower chamber. Onto the left side, we've got the left atrium, which is the top left chamber, and the left ventricle, which is the bottom left chamber. So that's the basics, those four chambers, okay, which looking at all the pluses in the chat, I can see you're confident with, which is good. The valves. I'm hoping you're confident with the valves as well. So we've got two sets of valves in the heart. These ones here, I'm just going to circle them. We've got the atrioventricular valves. Okay, you can see that label here. The AV valves for short, the atrioventricular valves. Easy to remember because they separate the atria from the ventricles, hence the name atrioventricular valves. okay? So we're all right with that. We're good so far. Let's think about the second set of valves. I don't know if you can spot them. We've got another set of valves. I'm just going to circle them. Another set of valves here. And they are the semilunar valves. Okay, so there's semilunar valves going into this blood vessel from the right ventricle, and another set of semilunar valves going into this blood vessel from the left ventricle. Okay, semilunar because they look like half moon shapes. That's why we call them the semilunar valves. Yeah, you actually don't need to know bicuspid and tricuspid. I think you do if you're doing PE for A level. I think they refer to them as bicuspid and tricuspid, but we're just going to refer to them as the atrioventricular valves. It's much easier to remember because you won't get them mixed up. AV valves, atrioventricular valves, separate the atria from the ventricle. Other question for you before we look at the blood vessels. Who has done a heart dissection? Let me know in the chat if you've already done a heart dissection. If you're in year 13, I'm guessing you have. If you're in year 12 or you're doing GCSE, you might not have done a heart dissection yet. Let me know in the chat. If you have, you'll have already seen these structures. Well, Celeste, you have. I love doing dissections in biology. It's my favourite practicals. Heart, lung, kidney. Yeah, it's the best practicals when you actually get to see the organs. So when you cut open the heart, oh good, loads you have, you'll see the atrium and the ventricle. The atrium is a lot smaller than the ventricle in reality, isn't it? The atrium is tiny compared to the ventricle. You also might have had the opportunity to see the valves. They're kind of like transparent, like flaps, aren't they, that you can just about see. Yeah, so good work. If you've done that already, I'm sure you had a great time doing the heart dissection. Let's move on. Let's think about the blood vessels. Okay, so this is probably the most complicated bit. If we're confident with our chambers and our valves, the next thing we have to know are the blood vessels. So this one here, they're colour coded for you on the diagram. So this blood vessel and this blood vessel are both the same. They're both branches of the vena cava. Okay, so the vena cava takes blood into the right atrium. There are two branches of the vena cava. We've got them in green on the diagram. Well done, Celeste. I was just about to say that, Celeste. You've jumped in, got it right straight away. You've got the superior vena cava at the top and the inferior vena cava at the bottom. You can just call them the vena cava. It's just two branches of the same blood vessel, the vena cava. But the superior one is obviously superior, it's on top, and the inferior is inferior because it's below. But they're both vena cava, so they'll be going into the right atrium, which is how you'll recognise them. Let's have a look at the purple one next. The purple one takes blood out of the right ventricle, and it's called the pulmonary artery. Whoop, bit wobbly there. So that's the purple one. Pulmonary artery, guys, we all know, don't we, that arteries carry blood away from the heart. So the purple one here is an artery. It's going away from the heart. And it's a pulmonary artery because it's going to the lungs. So whenever you see the word pulmonary, it means it's associated with the lungs. So this one, the pulmonary artery, is going away from the heart to the lungs. Over on the left side, we've got the pulmonary vein. Again, we've got two separate branches that we've got in orange, but they're both branches of the pulmonary vein, and they're going into the left atrium. Again, I'm sure you know this, but vein ends in because it's going into the heart. So all veins go into the heart, and it's the pulmonary vein because it's just come from the lungs into the left atrium. A few questions about the vena cava. If you're doing AQA biology, you can just say vena cava. If you're doing OCR biology, then this one is the inferior vena cava and this one is the sorry, this one at the top, sorry, I think I said the wrong thing then. If you're doing OCR, this one at the top is the superior vena cava and this one at the bottom is the inferior vena cava. But for AQA biology, we can just say vena cava. Okay? Yeah, exactly. No, probs just say vena cava. Yeah, definitely. If you're doing AQA, just vena cava. So we've got vena cava into the right atrium. We've got pulmonary artery leaving the right ventricle. We've got pulmonary vein coming into the left atrium. And the last one, which is this big red artery, is the aorta. Now the aorta takes blood out of the left ventricle all around your body. It's the biggest artery, it has the highest pressure, and you'll recognise it because it has this like distinctive C-shaped curve. So as it comes out of the heart and starts to branch off, you see this C-shaped curve. So that is your aorta. As I said, it's your biggest artery with the highest blood pressure coming from that left ventricle. Okay, now I'm going to move on because I think the majority of you all said you were confident with that anyway. And we've got a lot of content to get through today, so I'm going to move on. The labels are going to be on the screen again, so if you want to go through the labels again, just keep looking, keep checking you can label that heart. Okay, a couple of other things just to mention. When you think about your ventricles, the wall of the left ventricle, can you see how it's thicker here? The left ventricle has a really thick muscular wall. And if you've done the heart dissection, I bet you felt that. You will have known which was the right and which was the left because the left muscle is so much thicker. If you compare it to the right ventricle, can you see how much thinner that is? Right ventricle wall is much thinner. Reason being, the left ventricle, I'm sure you know, has to contract with a much greater force. It has to contract with enough force to create a much higher pressure, because remember, it's going to send blood out of the aorta and all around your body. So it has to be high pressure, which is why the left ventricle is so thick. Loving all your answers, all your little hearts as well in the chat. Yeah, put a little heart in the chat for me if you're liking it so far. If you're finding it useful, put a little heart in the chat. Other thing just to mention before we move on is the septum. I'm just going to draw some little lines on the septum. The septum is the little bit of muscle in the middle of the heart. Separates the right ventricle from the left ventricle. Where else in your body do you have a septum? Type it into the chat if you know where else in your body you have a septum. This is the heart septum here. Where else do you have a septum? The function, by the way, of the heart septum is to separate the right side from the left side. So it keeps the deoxygenated blood in the right side separated from the oxygenated blood in the left side. Some babies are actually born with a hole in the heart. And if there's a hole, just draw one on, if there's a hole in the septum, then the deoxygenated and the oxygenated blood can mix, which obviously is going to cause problems because you're not going to get enough oxygenated blood going around the body. Yeah, nose. Exactly. In your nose, you have a septum. That separates your right nostril from your left nostril. Same idea here. The septum separates the right ventricle from the left ventricle. Okay. Let's think about the valves. We've already mentioned the atrioventricular valves and the semilunar valves. They do the same thing, they're just in different places. Now, the purpose of your valves is to only allow the blood to flow in one direction. If you have a look at this top diagram here, when the valves are open as they are in this diagram, you can see the blood flows through in that direction. Okay, so it's going through when the valves are open. In this diagram, the valves have snapped shut. So when they're closed, we say that they prevent the backflow of blood. They stop blood going backwards, which obviously you wouldn't want to happen in your heart. You wouldn't want it to fall back into your ventricles or, go back into your atria. You only want it to go one way. So we say that the job of the valves is to make sure blood only flows in one direction, and when they close, it will stop the blood going backwards. Question about pleural fluid. We talked about pleural fluid last week. Pleural fluid is around your lungs. Between the pleural membranes around your lungs, you get pleural fluid. So not relevant for today, but it basically reduces the friction between the membranes of your lungs. You would not be asked to draw the heart from scratch, no. That would be a big ask, wouldn't it? Can you imagine? You'd have to be good at art to do that. You will not be asked to draw it from scratch, but you could be asked to label it. They'll probably ask you to label chambers or valves or blood vessels. Yeah, but you're not going to be asked to draw it. Okay, let's get into it then. So we know what the heart is. It's a muscular pump. The job of it is to pump blood around the body. And we've gone through the labels. I think you're pretty confident with the labels. If you do get the study notes afterwards, you will get the diagrams and the notes. So you'll be able to go back through it. I know someone just asked about the slides. The study notes basically match the slides. So everything that we go through, you'll be able to go back over and revise again and use them for revision for your exams. Okay, let's think about blood flow. So I'm going to draw some extra arrows on here. So we get blood going down the vena cava into the right atrium. So it's come from your body, deoxygenated at this point, in through the vena cava into the right atrium. From the right atrium, it's going through the AV valves. So it's going to push those AV valves open. It's going to go into the right ventricle. From the right ventricle, it's going to go up the pulmonary artery, and it's going to go to the lungs. Now, obviously, when it gets to the lungs, it's going to get oxygenated. So that links with another topic, which is gas exchange, which happens in the alveoli in the lungs. So blood goes to the lungs, it picks up oxygen from the air that we breathe. It then comes back to the heart. So I'm going to come back in. From the lungs, it goes down the pulmonary veins into the left atrium. It's going to push open the AV valves and go into the left ventricle, and then it's going to go from the left ventricle into the aorta, which is red, so you can't see my pen, but anyway, it's going to go all the way around the aorta, and it's going to be carried to your body, so all your cells receive oxygen. Okay, so you need to be able to picture this. This is where you need to do a bit of kind of visual learning. You need to picture the flow of blood, okay? And remember, it is flowing through both sides of the heart at the same time. So it's going into both atria simultaneously, opening the AV valve simultaneously, into the ventricles at the same time, then out of both ventricles, into the aorta and into the pulmonary artery at the same time. It's like two muscular pumps that contract together at the same time, isn't it? Okay, so it's going to be useful when you get your little study notes. It's going to be useful to get this diagram and make sure you can trace the flow of blood through the heart. Okay, moving on to the cardiac cycle. Just let me know if you are in an A-level biology class currently. Let me know in the chat if you have already done the cardiac cycle. That would be really useful. Let me know if you've already done it, or if you're in first year and you haven't, then, you know, hopefully this is going to be useful. It's going to give you a bit of a head start. But let me know if you have done this before. Celeste, we're not doing control of heart rate today. You're talking about the sinoatrial node and the atrioventricular node. We're not doing control of heart rate today. That's actually a separate topic where you do about the kind of the electrical impulses that spread across the heart muscle and make it contract. We're not actually doing that today, but that is something that we will definitely cover in our course starting from January. Brilliant. So you've done it, but it's going to be good revision. Your first year, you've not covered it yet. Okay. Whatever position you're in, it's either going to be good revision or it's going to give you a little bit of a head start with your A-level biology if you've not done it yet. So the cardiac cycle, it's a cycle because it happens over and over continuously throughout your whole life. This is what your heart is doing. So the first part of the cycle is atrial systole. So we have the atria contracting. Systole just means contraction, okay? So atrial systole is when the atria contract. After the atria contract, the ventricle contract. So we go to ventricular systole, ventricles contract. Then we have diastole, which is basically relaxation. So atria contract first, then ventricles contract, then diastole. The heart relaxes. Both atria and ventricles relax. Then it repeats. So we're back to atria contract, ventricles contract, then the heart relaxes, diastole. This is known as the cardiac cycle, okay? And we're going to go through exactly how that works, one stage at a time. So this is where it gets a little bit more complicated, but we're going to explain it as simply as possible. And do please keep typing into the chat. So if you've got any questions, make sure you type them in there. Right, let's go back to the beginning. So blood goes into the right atrium. So via the vena cava, I've just shown one branch of it on this diagram to make it simpler. Via the vena cava, it goes into the right atrium. Now you really need to be able to picture what is going on here. The atrium is filling with blood, okay? And they're going to start to contract, which is what these yellow arrows represent. So this is atrial systole. They're filling with blood and they're going to start to contract. Now, that is going to decrease the volume in this chamber. The chamber's going to get smaller, which is going to increase the pressure. Yeah, if you've got a smaller space, the pressure goes up. So blood's going into the right atrium. Atrial systole means the atria are contracting. The pressure is going to get really high in the atrium. That is what is going to force the AV valve open. So when the pressure gets really high in the atrium and it's higher than the pressure in the ventricle, it's going to push the AV valves open. It's almost like if you think about swing doors. I don't know whether you have swing doors in your schools or colleges, but if you've got like loads of students on one side of the door, you've got a high pressure pushing against those doors, they're going to swing open. So that's kind of what's happening here with our valves. The high pressure in the atrium is going to push those AV valves open. Okay, now at that point, obviously blood is going to start to flow into the ventricles. And remember, this is happening in the left side at the same time. Same time, blood is going into the left atrium. The atrial walls are contracting, so the pressure gets high in the left atrium, which pushes the AV valve open, so blood will start to flow into the left ventricle. Now that's atrial systole, that's atrial contraction. Let's move on to ventricular systole. So now the blood is in the ventricles. Think about what is happening then. The ventricles are now filling up with blood. And look at my yellow arrows. Not only are they filling up with blood, but they start to contract. This is ventricular systole. The ventricles start to contract. What is going to happen to the pressure in the ventricles? Well, they're filling up with blood. They're contracting. The pressure in the ventricles is getting higher and higher. When the pressure in the ventricles gets high enough, it's going to force open the semilunar valves. I'll do it on both sides because it's happening simultaneously. So the pressure in the right ventricle, the pressure in the left ventricle has got high enough to push open the semilunar valves. Okay, so the semilunar valves get pushed open. Think again about those swing doors. You know, the ventricle is full of blood. The blood's pushing against the semilunar valves. It pushes them open. So blood will now start to flow into the arteries, into our pulmonary artery and the aorta. Okay, so that's ventricular systole, ventricle contraction. Diastole, we said this was relaxation, didn't we? So after we've had atrial systole and ventricular systole, we go into diastole, which remember is relaxation. All the heart muscles relax. Both the ventricles and the atria relax. Now in terms of pressure, the pressure is now highest in the arteries because all the blood is in here. So all the blood has gone into the pulmonary artery and the aorta. The pressure is actually highest in the arteries, which means the semilunar valves are going to be forced shut. Okay, because the pressure is higher on this side of the semilunar valve than this side of the semilunar valve. That's going to make sure the semilunar valves snap shut, which is very useful because when the heart relaxes, I'm sure you can imagine, the heart's going to go, oh, it's going to relax. And there is a risk that the blood could just fall back into the ventricles. We do not want that to happen, obviously. We want the blood to go up the arteries and to the lungs or around the body. So we don't want it to fall back in, but it won't fall back in because the semilunar valves are closed. So it's going to continue on its journey and not fall back into the ventricles. That's the end of the cardiac cycle. It will then start again. So we're going to go back to atrial systole, which is atrial contraction, ventricle systole, ventricular contraction, and then diastole, where the whole heart relaxes. But because the semilunar valves close, the blood will not fall back into the ventricles. Okay? Right, let's go through some little tips then. These are my tips for you with regards to answering exam questions. Don't know if any of you have mocks coming up. Let me know in the chat if you've got any mock exams, or maybe not mock exams, maybe if you're in first year, you've got a January test coming up after Christmas and you're struggling with your revision. Let me know if you've got any exams coming up and what you think are going to be on them. These are things that I think, if you get a question on the cardiac cycle, these are like the 4 things that I would go through in my head and think, right, have I spoke about this? Have I spoke about this? I'd kind of check my answer and think, right, have I ticked all these boxes? So we'll go through them now together. Mocks in Jan, yeah, January seems to be the time for mocks, doesn't it? So if you're in year 13 and you're doing mocks in Jan, it's likely they're going to put some year 12 content on there, isn't it? You might have to do a year 12 paper as part of your mock, so this could definitely come up on that. Just finished them. Oh, that's early. You've just done your mocks. No cardiac cycle in 2023. Yeah, which means we can't be certain, but it could possibly come up in 2024. They do try and focus on topics that haven't come up recently. They'll try and put them on the papers, won't they? So look out for that. Good little tip. Go back through the papers and see what's not come up recently. Make a list of topics. I'll definitely do that for you. On the January course, if you join, I'll definitely give you a little list of things that haven't come up and make sure we do lots of revision on them. Right, let's go through this then. So these are my tips for a cardiac cycle question. Firstly, where's my pen? Sometimes I lose my pen on the screen. Right, firstly, talk about blood flow. Have you told the examiner where the blood is and where it's going to? So for example, it's going from the atrium into the ventricle, or it's going from the ventricle into the arteries. Okay, so talk about blood flow. Talk about what the muscles are doing. What is contracting and what is relaxing? Is the atria contracting or is the ventricle contracting? Or are they all relaxing? Are we in diastole, in which case the heart muscle is relaxing? Yeah, atria is just the plural. So you say 2 atria or 1 atrium. But it doesn't really matter on your exam. They're not going to penalise you for getting your singles and your plurals wrong. But thanks for answering that, Nur. Pressure, right. Talk about pressure. The cardiac cycle is all linked to pressure, as a lot of topics are in biology, particularly if we're thinking about the human body. So talk about where the pressure is higher. Is it higher in the atrium because the atrium is contracting, or is it higher in the ventricle because the ventricle is contracting? Where is it higher and where is it lower? That will affect the valves, you see, which is the 4th important point. The pressure is going to help you determine whether the valves are being pushed open or being snapped shut. So for example, if the pressure is higher in the atrium than the ventricle, it's going to push the AV valves open. But if it's higher in the ventricle than the atrium, it's going to snap the AV valves shut. So you need to understand the pressure, where it's higher, where it's lower, so you can link it to whether the valves are opening or closing. Okay? So let's go through my list. Talk about the blood flow, talk about the muscular walls, talk about the pressure, and talk about the valves. Okay? More tips for you, which are on my study notes. Which, don't worry, the moderators in the chat, I'm sure they're giving you the information. You will be able to get them if you stay on till the end of the stream. You can get these study notes. So more little tips. This is my tips to kind of link pressure and valves. Okay, so I'm going to do it on the diagram, I think, as well, just to help you understand. So if the pressure is higher in the right atrium than the right ventricle, the pressure is going to force the AV valve open. But if the pressure in the ventricle is higher than the atrium, that's going to force that valve to shut, because you don't want any blood to go backwards. Okay? Now let's think about the semilunar valves. If the pressure in the ventricle is higher than the pressure in the artery, that's going to push the semilunar valve open, isn't it? Yeah, if you've got high pressure in here, it's going to push on that valve, it's going to open it. But once the blood goes into the artery, when the pressure in the artery is higher than the pressure in the ventricle, it's going to push back on that valve and make it shut. So picture your swing doors. There's pressure on one side of the swing doors, it's going to push them open. But when the pressure gets higher on the other side, it's going to snap them shut. Okay? So AV valves, we're going to look at this on a graph in a second as well, so that will really test you. But AV valves, which are these ones here, open when the pressure is higher in the atrium, and they snap shut when the pressure gets higher in the ventricle. And then the semilunar valves, which are these ones here, they open when the pressure is higher in the ventricle and snap shut when the pressure gets higher in the artery. Okay, I think we're going to look at it on a graph. This looks pretty scary, but it's really not, okay? In fact, I'm going to show you the next graph because I think, yeah, it moves it over so my head is not blocking the words. It looks scary, but it's not. When you get a graph in an exam, spend a bit of time, look at the axes, make sure you know what it's actually showing you before you start to write, okay? This graph has got pressure on the y-axis. In kilopascals, it's the pressure. And it's giving you three pressures. Look over here. The pressure in the aorta, which is an artery, the pressure in the ventricle, and the pressure in the atrium. You've got three lines. The ventricular pressure is in orange, the aorta pressure is at the top there in red, and the atrial pressure is down the bottom in red. Now basically, the graph is showing you the changes in pressure. Now let's have a look. Let's look at this point here. In the exam, they could ask you what happens at that point. And you have to look at the pressures to figure out what would happen at that point. Now I'm hoping you can see in the bit that I've circled, the orange line, which is the ventricular pressure, is going above the atrial pressure. So we've got pressure in the ventricle higher than pressure in the atrium. So what's going to happen? The AV valve is going to close because the pressure in the ventricle is higher. Let's look at this one here next. Hopefully you can see the red line is now higher than the orange line. So now we have the atrial pressure higher than the ventricular pressure. Now when the pressure in the atrium is higher than the pressure in the ventricle, that will push the AV valve open. Okay, so pressure higher in atrium pushes AV valve open, but over here the pressure was higher in the ventricle, which pushes the AV valve closed. Let's look at these ones which are linked to our semilunar valves. This one here, the orange line, the ventricular pressure, has just gone above the aorta pressure, the artery pressure. When the ventricular pressure goes above the pressure in the artery, it pushes the semilunar valve open. And over here, we've got the pressure in the aorta. If you look, I know it's hard to see, but the red line is now above the orange line. So the pressure in the aorta is now higher than the pressure in the ventricle. And that's what pushes the semilunar valve closed. Okay, so you've got pressure changes linked to valves opening and closing. It looks complicated, but it's really not. All you've got to do is look at the lines carefully. Where's my pen gone? Look at the lines carefully. Like, let's look at this one again. If you look carefully at those lines, you can see the red line is higher than the orange line. The red line is the aorta pressure. The orange line is the ventricle pressure. If you look at that point, the red line has just gone above the orange line. So the aorta pressure has exceeded the ventricle pressure. And when the aorta pressure is higher than the ventricle pressure, the semilunar valves have to close, or the blood could just fall back into the ventricles. Okay. Right, so this is what you might get in an exam. So there's no labels on this. I've told you what each line is. So we've got another pressure graph. We've got pressure in the atrium, pressure in the ventricle, and pressure in the aorta, which is the artery, don't forget, the artery on the left side of the heart. So they could ask you to say what is happening at each of the labelled points. So this labelled point here, something's happening. It's going to be a valve, it's going to be opening or closing, you just have to work out what it is. This one here, down here as well, it's anywhere you get pressure lines crossing over. Anywhere you get pressure lines crossing over, there's going to be a valve opening or closing. Okay, let's go through it together. So we've got ventricular pressure is creeping above the aorta pressure. That is going to push those semilunar valves open. So semilunar is going to open. But over here, the aorta pressure is now higher than the ventricular pressure. So semilunar valves are going to have to close or the blood is going to flow back into the ventricle. Down here, the atrium pressure has crept above the ventricle. Type into the chat for me if you know what's happening at C. Let me know if you're following. So at C, the atrium pressure is higher than the ventricle pressure. If the pressure in the atrium, you need to picture it. I don't know about you, but I'm picturing the heart in my head. If the pressure in the atrium is higher than the pressure in the ventricle, what is going to happen there? Type it into the chat. It's going to be a valve. It's going to be opening or closing. You just need to know which one it is, what it's doing. The pressure in the atrium is higher than the pressure in the ventricle. Yeah, exactly. The AV valve, you must be picturing it. The AV valve is going to open. Yes, because the atrium pressure is higher. It's pushing the valve open. Whereas at D, the AV valve is going to close because can you see the ventricle pressure has now crept above the atrial pressure? Perfect. When the atrial pressure drops lower and the ventricular pressure goes higher, the AV valve snaps shut. It's got to, otherwise the blood could go backwards. Okay, and we don't want that to happen. That's the whole point of these valves. Okay, let's have a look at a question. So, which part of the heart is represented by curve X? Type your answer into the chat. It's obviously another pressure graph. This is taken from an exam paper. Some of the lines have been labelled. In fact, 2 of the lines have been labelled, but curve X has not been labelled. So what do we think curve X is representing? Type your answer into the chat, please. You can also answer question 2 in the chat as well. Which side of the heart is represented on the diagram and how do you know? Type your answers into the chat. Harvard University, how do you know if it's higher or lower? Think about it. If it's filling up with blood and the chamber is contracting, it's going to have a higher pressure. So if it's filling with blood, if the atrium is filling with blood and the atrium is contracting, the atrial pressure will be higher. If the ventricle's filling with blood and the ventricle is contracting, the ventricular pressure will be higher. Good, it's the atrium. In fact, some of you gave me very specifically, it's the left atrium. It's the left atrium and it's the left side of the heart. I mean, there's a bit of a clue on the graph, isn't there? It's obviously the left side of the heart because we've got the left ventricle and we've got the aorta. The aorta is the blood vessel that leaves the left ventricle, so it's got to be the left side of the heart. Okay, harder question, question 3. Between which times are the semilunar valves open? Have a little think. Let me give you a bit of help with this question. When will the semilunar valves open? They will open when the ventricular pressure I'm just going to abbreviate that. When the ventricular pressure is higher than the aorta pressure, they will open. And when will they close? Semilunar valves will close when the ventricular pressure is lower than the aorta pressure. Okay, so they open when the ventricular pressure is higher than in the aorta, they're forced open. Then they close when the ventricular pressure drops lower than the aorta pressure, because when it's higher in the aorta, it's going to push those valves close. That is a good answer. Shall I mark it on? You might even remember from the previous graph, but they're going to open here and they're going to close here. So I'll just put open and close. So they're going to open here because the ventricular pressure at that point has gone above the aorta pressure. They're going to close here because the aorta pressure has now gone above the ventricular pressure. Now in your exam, guys, you get your ruler out and you draw a line down I'm not going to be able to do it straight on here, but you draw your line down to the x-axis, because if you don't use your ruler, you are not going to read that off accurately. My lines are awful. Yours are going to be better. You're using a ruler. So I think your answers are good. I wrote down 0.14, 0.14. Wow, Tau, you've got 0.14, and yeah, you've got exactly what I got. 0.14 and 0.4. So between those times, so from here to here, semilunar valves are open. Once you get your study notes, you can do that properly for me. You can get your ruler, draw your lines down and read off, because it's good practice as well to make sure that you can actually read a scale on a graph. Check that you can read the scale accurately. Okay. Last question. Do you know what? I'm not going to help you with this. I'm just going to leave this on and see if you can do it. This is kind of random, not quite linked to today's topic, but using this graph, you could actually calculate the heart rate of this person. I want to know if you can do that. Calculate the heart rate. Remember, the heart rate is how many beats per minute. And you could figure that out from this. You just need to kind of identify the start of the start of one cardiac cycle and the start of the next. I'm just going to see if you can do that, I think. And then if no one puts any answers in the chat, I will do it with you. How did you do that so quickly? How someone has already given the right answer. You did that so quickly. That is impressive. That is quicker than how I could do it. Particularly if I was looking at it on a screen, I think I'd find that hard. You've done that so quickly. And Venki as well, you've got the right answer. It's not 54. Calculator. Yeah. You're always going to have a calculator in the biology exam, aren't you? I still see students that are trying to do things by hand, and I'm like, why would you not use your calculator? You've got it there, use it. Even if it's just to double check your answer, definitely use it. Right, okay. Those of you that haven't answered, I'm going to show you how to do it. You're going to identify the start. Well, it doesn't even have to be the start. You just need to identify where the cardiac cycle starts to repeat itself. So I can identify those 2 points. I think that's the most obvious. Because at 0.1, that's when the ventricular pressure starts to shoot up, right? And I found the same point repeated. At 0.9, the same thing happens. The ventricular pressure starts to shoot up. Now, if I work out the difference between 0.1 and 0.9, which I actually don't need a calculator for, can do a bit of maths. The difference is 0.8. So that's telling me that one cardiac cycle takes 0.8 seconds, one complete cardiac cycle. So heart rate is how many beats per minute or how many cardiac cycles per minute. Now, obviously in a minute there are 60 seconds. So I just need to find out how many cardiac cycles would fit into a minute. So 60 divided by 0.8 would give us the answer of 75 beats per minute. And I got that literally just by identifying like the start of one cycle and the next cycle, the same points on the graph where it repeats itself. Okay, and then seeing how many of those would fit into a minute. Okay, I'm hoping you found that useful. We went through a lot, but I've got to be honest, you all seemed really on the ball today. You all seem to know your heart structure. Cardiac cycle, which can be challenging, I'm hoping you found that useful, and your heart rate answers were spot on. Right, let's give you a bit more information then. Those of you that have found it useful and want to talk about acing their biology exam, so you want to make sure you get your A or your A star, let's talk a little bit about the course. The course is launching in January. It's an A-level biology course, and it's going to be with me live, so just like this, live lessons. We're going to say stress-free. I know exams can be stressful, but we are aiming to limit your stress. You're going to spend 4 hours a week. So, less than 5 hours, it's nothing. Less than 5 hours, just 4 hours a week. You are going to have 2 live classes per week. So 2 classes, each class is 2 hours long. So 4 hours a week of live lessons that take place on YouTube. On top of that, you will get homework with each of the live lessons, which will be like exam style questions. You'll also get study notes in the form of workbooks that go with each lesson. You will also get access to the community of biology students. So you'll be able to chat to each other, support each other, ask questions, get tips and advice on revision. You can also get your own mentor. So as well as having my lessons, you can get a one-to-one mentor experience where basically you can message them if you've got any queries, if you want help with your homework, if you want extension questions, help with essay writing, exam technique. You can message your mentor at any time, 24/7, and they will support you. Our mentors, by the way, are amazing. They've all got A's or A stars in biology. So they've done their A level, they've got an A at least, or an A star. Some of them have even been to uni, done degrees, or they're currently studying medicine, for example, at university. So you get that as well as my interactive lessons and workbooks and homeworks. You also get, so if you sign up for the course, once it starts in January, you get a 14-day money-back guarantee. So it is basically totally risk-free because you can try the lessons and you can access the homeworks and the workbooks, you can access your mentor, and if for whatever reason you're not happy or it doesn't suit you, you can get your money back within 14 days of starting the course. Okay, so it's risk-free because we want to make sure it's the right thing for you and that it is going to help you achieve your A-star grade that I know you all want. Just some figures about My Ed Space. Currently we have over 1,300 students studying with My Ed Space and 90% of them would recommend the courses. 82% of students have gone on to achieve, so these were students that did exams last year, they've gone on to achieve a higher grade than they expected or were predicted by doing their extra lessons and homeworks, etc. If you have a little look on Trustpilot, if you look for My Ed Space on Trustpilot, you'll see there are hundreds of 5-star reviews, mostly about maths. But obviously we've got biology and chemistry launching in January. So yeah, have a little read of all the reviews. They describe how positive their experience has been and how useful they found the interactive lessons. If you like the sound of the course and everything that it includes, put a little plus in the chat just to let me know so I can see who's interested. I know particularly biology A level, it can be challenging, it can be a lot of work, there's a lot of revision that needs to go into it. So if you do want help with that and you think this is going to be useful, put a little plus in the chat. The original course price is £700 for the full course, taking you from the beginning of January all the way up to your exams. But if you stay tuned, I will talk to you about how to get a massive discount on that price, okay? Just a reminder of what you get as well. You get your live lessons, you get your revision notes, which are all professionally designed, better than any revision guide or textbook. You get your homework, you get detailed video solutions, so I will talk you through each and every homework, where you may have gone wrong, what you need to say to get full marks. You can access those videos at a time to suit you and go through all of your homeworks. You will join the community of biologists, so you'll get a whole network of support. By the way, all the live lessons are recorded, so you can access them and watch them back anytime to suit you. And you get 24/7 support from your mentor, who is very knowledgeable. We've got a whole team of knowledgeable mentors who can support you with all your homework queries, revision queries, etc. A lot of you are asking about price. The original price was £700. Because we are doing the free streams currently, if you sign up through one of the free streams because you've been in attendance, you can get 44% off, which basically takes the price down to £393. So much cheaper than a private tutor. I don't know if you want to type into the chat, let me know if any of you actually pay for a private tutor. I know they can be incredibly expensive, and sometimes you only get like 1 hour a week with a private tutor, and it might be £60-70 a week. Whereas with this, with the discounted price, I think it works out £4.90 an hour of lesson time, which is much, much cheaper. So yeah, I'd be interested to know if any of you do have tutors. With the discounted price, you can split it into 2 equal instalments, so you can pay half up front and then half in January. Yeah, tutors are expensive, so this is basically a way of getting, well, it's better than a tutor because it's 4 hours a week, as well as homework, as well as support, and workbooks, which you don't always get with private tutors. I used to do a lot of tutoring myself, and the most really I could spend doing it was an hour a week. Whereas with this, it's 4 hours a week and it works out much, much cheaper. So the discount, the 44% off, is going to be valid until midnight on Friday. So if you do want to sign up, you need to do it before Friday. You can do it by messaging me on WhatsApp. Basically, if you go onto the description on today's YouTube stream, in the description there is a link. If you hit that link, it will automatically take you through, and the word heart will be pre-filled in, so you can just send it to WhatsApp, and that will let someone in my team know that you're interested, and they will be able to give you more information or sign you up. Yeah, so click the description in the link. Okay, just a few other questions to go through. If you miss a lesson, do not worry, they are all recorded. Okay, they're all recorded, you can watch them in your own time. If you miss a lesson, you can go back and watch it at a later date. You can watch them as many times as you want. Your personal mentor will give you as much attention as you need, so they will be on hand 24/7 to answer all of your questions, help you with homeworks. Don't forget as well, just like we've done today, during the live lessons themselves, I will answer as many of your questions as I can, and the moderators in the chat will answer all your questions as well. So you will get plenty of attention during the live streams, and you can chat to each other and help each other out as well, like you've been doing tonight. Asking for help, obviously in the chat, like I've just said, during a live stream. Ask your mentor any questions. Ask in the community. You'll be added to our biology community, so you can chat all things biology, give each other advice, support, etc. I'm really hoping the lessons will be useful to you. Don't forget, I've been teaching, this is my 16th year of teaching, so I've been teaching A-level biology for almost 16 years. Old spec, new spec, OCR, AQA, everything. I'm really hoping that they will be useful. I try to explain things in as simple a way as possible and as clearly as possible. And like I say, we will answer your questions in the chat. Don't forget though, you do get that 14-day money back guarantee. So if for whatever reason it doesn't suit you, it is risk-free. You can get a refund within 14 days of starting. So let me know if you're interested. Click the link in the description, which will send the word heart through to our WhatsApp. You can get as much information from the team. You can sign up today. Remember, the discount does expire at midnight on Friday, using this phrase heart. So yeah, go on the link now, send it off, even if it's just for more information, and we'll get you signed up. Okay, I hope that's been useful. I will see you again soon, hopefully. Next Wednesday, we are doing another free stream, same time, 5 p.m. So I'd love to see you all there. because some of your answers were fantastic. You've worked really hard. Okay, I will leave you to it. I'll leave you to enjoy your evening. Thank you for joining me, and I hope to see you again soon. Thanks, guys.